Hey everyone, welcome back to the channel. Today we're diving into something really exciting. We're going to learn how to build a custom plugin for Claude Cowork from absolute scratch. If you've been wanting to extend Cowork's capabilities with your own tools and integrations, this tutorial is for you. By the end of this video, you'll have built a fully functional plugin that you can actually use in your workflow. Let's jump right in. Here's what we'll be covering today. First, we'll understand what Cowork plugins are and why they're powerful. Then, we'll set up our development environment with all the tools we need. Next, we'll build our first plugin step by step. We're creating a weather information plugin. After that, we'll test it thoroughly to make sure it works perfectly. And finally, we'll deploy it so you can actually use it in Cowork. So, let's start with the basics. Before we build a plugin, let's quickly understand what Claude Cowork is. Cowork is Claude's desktop application that helps you automate file and task management. It's like having an AI assistant that can actually interact with your computer. But here's the magic. Cowork uses something called the Model Context Protocol, or MCP, which allows it to connect with external tools and services. And that's where plugins come in. So why would you want to build your own plugin? First, you can extend Cowork's functionality with custom tools specific to your workflow. Second, you can integrate third-party APIs and services that aren't available out of the box. Third, you can create internal tools for your team that leverage AI capabilities. For instance, today we're building a weather plugin, but you could build plugins for your CRM, your database, your custom APIs, anything. All right, let's set up our environment. Before we start coding, make sure you have these prerequisites installed. First, you need Node.js version 18 or higher. This is essential because we're building with TypeScript. Second, you'll need Claude Cowork installed on your machine. You can download it from claude.com. And third, a code editor. I recommend VS Code, but use whatever you're comfortable with. Got all that? Great! Let's create our project. Now let's create our plugin project. Open your terminal and follow along. First, create a new directory for your plugin. I'm calling mine Weather MCP Server. Navigate into that directory. Now initialize a new Node.js project with npm init-y. Next, we need to install the MCP SDK. Run npm install @model context protocol /SDK. And let's add TypeScript as a dev dependency. npm install --save-d TypeScript @types/node. Perfect. Your project structure is ready. We need to configure TypeScript for our project. Create a file called tsconfig.json in your project root. This configuration tells TypeScript how to compile our code. We're targeting ES 2022 using common JS modules and enabling strict type checking for better code quality. I'll show you the exact configuration on screen, and you can copy it from the description below. Now we're ready to start coding. Let's set up our file structure properly. Create a source folder. This is where all our code will live. Inside source, create a file called index.ts. This will be our main server file. Your project should now look like this. You can see the structure on screen. Now let's write some code. Open index.ts and let's start by importing what we need. First, we import the server and stdio server transport from the MCP SDK. These are the core building blocks of our plugin. The server class handles all the MCP protocol communication, while stdio server transport allows our plugin to communicate via standard input-output. Here's what that looks like. Now let's create our MCP server instance. We create a new server object with configuration metadata. Notice we're giving it a name, weather server, a version number, and these capabilities flags. The tools capability is set to an empty object, which tells Cowork that our plugin can provide tools. This is crucial. Think of this as registering your plugin with Cowork and telling it what your plugin can do. Here's where the magic happens. Let's define our weather tool. We use server.setRequestHandler for tools/list to tell Cowork what tools our plugin offers. Our tool is called Get Weather, and it has a clear description that Claude will use to understand when to call it. We define an input schema using JSON schema that requires a city parameter of type string. This schema tells Claude exactly what information it needs to collect from the user before calling our tool. So when a user asks, "What's the weather in London?" Claude knows to extract London as the city parameter. Now let's implement what happens when the tool is actually called. We set up another request handler, this time for tools.call. When the tool name is getWeather, we extract the city from the arguments. Here's where you'd normally call a real weather API. For this demo, we're using mock data, but I'll show you how to integrate a real API in a moment. We return the weather information in a structured format that Claude can understand and present to the user. And if someone tries to call a tool that doesn't exist, we throw an error. Let's make this more realistic by adding a real weather API. We'll use the Open Weather Map API. It's free and easy to use. First, install the Node.js package for making HTTP requests. Here's how you'd modify the code to call the actual API. Notice we're using async await because API calls are asynchronous. In production, you'd want to store your API key in environment variables, not hard-coded. The last piece of our code, starting the server. We create an async main function that initializes everything. We create the stdio server transport and connect it to our server. We wrap it in try-catch to handle any startup errors gracefully. And finally, we call main to start the server. And that's it. Our plugin code is complete. Before we can use our plugin, we need to compile the TypeScript to JavaScript. Open your package.json and add a build script. The script runs tsc, which compiles all our TypeScript files. In your terminal, run npm run build. You should see a new build folder with your compiled JavaScript files. If you see any errors, double-check your code against the examples. Now, let's tell Cowork about our new plugin. We need to edit Cowork's configuration file. The location depends on your operating system. On macOS, it's in tilde/library/application support/claude.desktop_config.json. On Windows, look in %appdata/claude/claude.desktop_config.json. Open this file in your code editor. Let me show you what to add. Here's the configuration you need to add. Under the MCP servers object, add a new entry for your weather server. The command is node, and the first argument is the full path to your compiled index.js file. Make sure to use the absolute path. You can get this by running pwd in your project directory. It should look something like this on screen. Save the file and make sure the JSON is valid, no trailing commas. To load your new plugin, you need to restart Cowork. Completely quit Cowork. Don't just close the window, actually quit the application. Start Cowork again. When it starts up, it will read the configuration and load your plugin. You should see your plugin in the Connected Tools list. Let's test it out. Time for the moment of truth. Let's test our plugin. Open a new conversation in Cowork. Try asking, "What's the weather like in Tokyo?" You should see Cowork recognize your query, call the weather tool, and return the information. If it works, congratulations! You just built your first Cowork plugin. If it doesn't work, don't worry. Let's troubleshoot. Here are the most common issues and how to fix them. Plugin not appearing. Double-check the path in your config file is absolute and correct. Server crashes. Look at the error logs. Usually it's a missing dependency or syntax error. Tool not being called. Make sure your tool description is clear and specific. JSON errors. Validate your config file. Even a missing comma can break it. You can check Cowork's logs for detailed error messages. Here are some advanced test cases to try. Ask for weather in multiple cities in one query. Try different phrasings like, "How's the weather in Paris?" versus "Paris weather." Ask follow-up questions to test context handling. Try edge cases like invalid city names. Good testing ensures your plugin works reliably in real-world use. Now that you have the basics, here's how to take it further. Add more tools, forecast, weather alerts, historical data. Add error handling and validation for better user experience. Implement caching to reduce API calls. Add support for coordinates, not just city names. Create prompts to help users discover your plugin's features. The possibilities are endless. Here are some other plugin ideas you could build. Database connector, query your databases with natural language. CRM integration, manage contacts and deals. Task manager, create and track tasks. Code analyzer, analyze code bases and generate documentation. File converter, convert between different file formats. API wrapper, make any REST API accessible through natural language. What will you build? And that's it. That's how you build a plugin for Claude Cowork from scratch. We covered setting up the environment, writing the plugin code, configuring Cowork, and testing everything. Now you have the skills to extend Cowork with any functionality he can imagine. If you found this helpful, please like and subscribe for more Claude tutorials. Drop a comment below telling me what plugin you're going to build. I'd love to hear your ideas. Thanks for watching, and I'll see you in the next video. Happy coding!